much as we can. Mm-hmm. Sorry, I'm like a mouthful away from finishing it. There we go. Tap down. All right. Because I don't think we did this one yesterday. Yes, this is still 2.1. We're going to finish 2.1 today. So what we're going to do is we're going to find our denominator or the pieces in the denominator that we need so that we can get rid of all the fractiony goodness. So since we're looking at fractions and I have this x squared over here, let's simplify this guy first. Holy chunky pen Batman. Try that again. That one. Okay, pen. Can we get this together, please? Thank you. Just pull yourself together, iPad. So when we look at this 4x squared minus 1, how can I write that in factored form? Yep, it's the difference of perfect squares. This is 2x plus 1 and 2x minus 1. Which are exactly the pieces we have on the other side as far as denominators go. It's just missing parts of it. So if you think about it as the common denominator, what we're going to get is going to just be the 2x plus 1, 2x minus 1, right? That's going to be our denominator for everybody. What are we going to do next? We're going to multiply. And you can either multiply like the pieces that are missing, or you can multiply everybody by that common denominator. X plus 1, 2x minus 1. 2x plus 1, 2x minus 1. So if I multiply everybody by that common denominator, I can simplify each of these pieces and get rid of the fractions. Because 2x plus 1 cancels out, leaving us with 2 times 2x minus 1. Minus 2x minus 1's cancel out. 3 times 2x plus 1. This guy cancels and that guy cancels. And we just get our 2x minus 2x plus 7 over here. There's a few different paths you can get to wind up at this statement. There's a few different ways to get here. As long as you wound up here, you're fine. Because you can multiply this by 2x minus 1 over 2x minus 1. You can multiply this one by 2x plus 1 over 2x plus 1. You should still wind up here. So there's a few different ways you can get there, but you should wind up here. Questions on how we got there? And then what we do is we simplify. There's no more fractions. We just have x's. So we're going to distribute. And we're going to get 4x minus 2 minus 6x minus 3 equals minus 2x plus 7. And then we're going to simplify. So we've got 4x minus 6x on this side, which gives us minus 2x minus 5 equals minus 2x plus 7. And what do we need to do? Add 2x on both sides. When we do that, what's going to happen? they cancel out. And we're left with -5 equals 7. What does that mean? It's false. That's something that doesn't work. So what's our solution? No solution. This is inherently false. That is a thing that does not happen, which means no solution. No matter what x is, no matter what y is, -5 does not equal 7. Just like no time in the world does that happen. If I got something that was inherently true, what would we get? What if I got, so we're just imagining now. What if I got 3 equals 3? Infinitely many solutions, because no matter what x is, no matter what y is, 3 equals 3. Like it just does. So this is we were imagining. Our answer here is no solution. Okay, so no solution is a valid answer. Infinitely many solutions is a valid answer. Okay. One more of these and then they will start to look less gross. All right. So we've got 9x over 3x minus 1 equals 2 plus 3 over 3x minus 1. What is our common denominator going to be? 3x minus 1. We only have the one piece in there. So we can multiply everybody by that common denominator, 3x minus 1, by 3x minus 1, by 3x minus 1. Because I would like to make those fractions go away. Thank you very much. Ooh, come on, pen. There we go. Fix that because that looked terrible. There we go. That's going to give us, that guy cancels and that guy cancels. We get 9x equals 2 times 3x minus 1, 6x minus 2, making a jump there, plus 3. We multiplied these together and I just distributed them here. If you need to write out more steps, that's fine, but I'm also okay with us jumping steps, combining things together. As long as we're careful. Because what we get is 9x equals 6x plus 1. And then subtract the 6x from both sides. And we get 3x equals 1. So what does x equal? X equals 1/3. Does that work in my denominators up there? If I substitute 1/3 in for x, is it going to work? Why not? Because my denominator is going to equal 0. 3 times 1/3 minus 1 gives us 1 minus 1, which is 0. And we can't divide by 0, right? So this solution is extraneous. I heard somebody say it. That's so extra. They made us do all that work. Oh, my God. That's so extra. So it's extraneous. Since we don't have any other options, what's our solution here? No solution. There's no valid solution. They made us do all this work and we didn't even get a valid answer. It's so extra. Oh my God. Oh my God. My Algebra 2 kiddos get really sick of me saying it like that. But you know what they do? Remember it. And see if they hear me going, oh my god, it's so extra. So extra. Oh my god. They get really tired of that voice too. My very basic. It's so basic. Oh my god. All right. Questions on this one? The last bit of 2.1 is we play with letters. These are called literal equations because literally they're made of letters. Like literature is made of letters. Literal equations are made of letters. Literally. Oh my god. Sorry, once I start, I can't stop doing the voice. I can't stop. All right. So let's just look at one at a time. If I told you to solve this for L, get L by itself, what do? Multiply by L. Multiply both sides. Get L out of that denominator. So times L. So we get R times L equals V. That is a V. It's just all scripty and weird. I don't care if you call it U or V. It's close to dang enough. How do I get L by itself? Divide by R. Capital R. I'm going to keep the font the same. So that we get L equals V over R. Ta-da! That's our answer. There we go. Then we have a volume formula over here of a pyramid, I think. Volume of a pyramid. Or cone. It's been a minute since I did geometry though, and I don't remember which one that is. I think it's a cone. But we're asked to solve this for H. There's a whole lot of gross in there. Treat them like letters. It don't matter. Pi we treat like a letter. So if I need to get in here and get H by itself, what do we need to do? I had lots of ideas there, and it all kind of blended together. So we can multiply by what? 3. That'll get my 1/3 to cancel out. What do I need to do with my pi and my r squared? Divide by pi and r squared. And you can, again, do that all in one go if you want to. If you can keep that straight in your head, you can do it all just like that. I count that as show and work. So we wind up with 3 times the volume over pi r squared equals, and that guy cancels out with that guy, H. And that's the answer. We got H by itself. When it says solve for a variable, it means get that piece by itself. All right, hardest one. If you need, do you need that still for a second? You okay? All right, this is the last one. Last one. We've got S equals P over Q plus P times the quantity 1 minus Q. I believe this is a physics thing. Like, it's a thing. I don't know why we need this thing, but it's a thing. And what we're going to do is we're going to solve for Q. So what do we need to do? What's our instinct? Multiply by the denominator. Get it out of the denominator first things first. So multiply by Q plus P times 1 minus Q. So I get S times that whole rigmarole. Q plus P minus 1 minus Q. Sorry, that 1's really smushed in there. Let's try that again. Equals P. All right, we're still looking to get Q by itself. What can I do? Divide by S. That is definitely going to be our easier way to go right here to get this S out of the way. And I'm actually, while we're writing this next step, I'm going to do this P times the 1 minus Q distribution thingy here. So we get Q plus P minus QP equals P over S. You see how I did that? I did that distribution right here. So my S's canceled. This S canceled with this S. And then I did this distribution here to give us these two pieces.
Why didn't you distribute it to Q?
Because it's not a quantity Q plus P times 1 minus Q. It's just P times that. Like this guy here. Okay, there we go. I heard that one quick. Okay, we're still trying to get Q by itself. So is there anything over here that has no Q's that I can get rid of? P. Let's subtract that P. Minus P from both sides. So we have Q minus QP equals P over S minus P. A whole lot of P's up there. Look at that left side and see if there's any way we can rewrite it so I only have 1 Q. What was it? Not by P. Factor it. Those two pieces have a GCF of Q. These have a GCF of Q. So we can rewrite that piece as Q times 1 minus P. And I'm rewriting that because that looks crazy pants. 1 minus P. Yes? P over S minus P. I don't really care what the right side looks like. The right side can be a hot mess of crazy. I want Q by itself. What can I do to get Q by itself? Divide by 1 minus P. Divide this side by 1 minus P. And that's our answer. It looks gross, but that's valid. There are ways to simplify it, but I don't really care if we do. I don't really care. If you want to know what it looks like simplified, you get common denominators on the top. And you could do that. You don't have to. I'm fine with this. Okay? That is the end of 2-1. So you can do the whole homework for 2-1. Yes. I always give you a day of grace, so if we need a day of grace, take a day of grace and get it to me by Monday. If we need a day of grace, just because I know this was a lot, and sometimes these take a minute, I think you'll be all right. It's not a ton of questions, but if we need the day, take the day. Those are the question numbers. It's not a ton of questions. Like, you'll be all right. Okay? Less than a minute to the bell. Haha, I wasn't wrong. I was not wrong. I started talking before it. That's why I always say less than.